In this video, I'm going to remind you how to solve systems of equations using matrices. Now there are two methods that I have to show you. I'll probably split them into two different videos. I have two examples, so here I go. The first method I want to show you is called solving by matrix equations. So I'm going to write by matrix equations. I think this may be most people's favorite method as far as using matrices, but everybody has their own style. So by matrix equations, what do I mean by that? I mean you write yourself an equation like, very simple, like the equation A times X equals some other number B. Now before I actually show you how to do it, demonstrate it, I just want to give you a little background. If you had this little equation to solve and you were looking to solve this variable X, you would probably think divide both sides by A, which there's nothing wrong with because that is an inverse operation of multiplication. But what I really want you to think about is multiplying both sides by the reciprocal of A, namely the inverse of A. So A times its inverse would cancel it out from the left-hand side, and then its inverse times B would give us the answer to X. I'll show you what I'm talking about when I do the problem. So if I were to take my first equation, or my first matrix, my first system, and write it as a matrix equation, it would look something like this. I would write the coefficients of x and y become my first matrix, 1, -3, -5, and 16. Close that matrix, multiply it by a matrix that's a 2 by 1. This is my variable matrix, x, y. And it's going to equal the constants, -1, 5. Now in this method, what I'm showing you is you're going to take matrix A, you're going to find its inverse, and multiply both sides by its inverse. So it takes a little side work. So do you remember how to find the inverse of a matrix? If I'm going to find I'll do it over here. If I'm going to find the inverse of matrix A, the way I do it is I find the determinant of this matrix first. So 1 times 16 minus -5 times -3 is a positive 15. 16 minus 15 is 1. How convenient is that? This is the determinant. Then what I do with the determinant is I should have said the determinant of A, not the inverse of A. The determinant of A is 1. Then to find the inverse of A, I'm going to write 1 over the determinant. I know you're thinking 1 over 1 is 1. I know, but I want you to get in that habit. Down here is where the determinant goes. And then you're going to multiply it by not this matrix, but the adjusted version of that matrix, where we switch A and D and negate the -3 becomes a positive 3, negate the -5 becomes a positive 5. And essentially 1 times this whole matrix is going to give us 16, 3, 5, 1. That doesn't normally happen, but when it does, be happy. This right here is the inverse that I'm going to multiply on both sides of my equation. So I'm not going to bother writing it here because I know it's going to cancel out. So my answer is going to look something like this. The setup of my answer will look like this. I'll take x, y, my variable matrix, make it equal to my inverse matrix, and by the way, the order matters. You have to put your inverse matrix in front of your constant matrix or it won't work out. Actually, you'll probably just discover it on your own. You wouldn't be able to multiply it. Let me show you really quickly what I mean. What kind of matrix, what dimensions are these? Is this matrix? It's a 2 by 2. What's this one? A 2 by 1. So you understand that it has to be in this order. I can multiply these two matrices because the inside dimensions match. If I had written this orange matrix over here, I would not have been able to multiply because the inside dimensions would not have matched. All right, here I go. The answer, I mean really, it's this easy. People are kind of frightened by it for some strange reason. All I need to do is multiply this matrix times this matrix. Remember, we can do it because the inside dimensions match. The outside dimensions tell me what my answer matrix is going to look like. It's going to be a 2 by 1. 2 rows, 1 column. Hence, the answer for x, the answer for y. So here I go. 16 times -1 is a -16 plus 3 times 5, which is 15. I'll add them together in just a minute. Then for second row, 5 times negative 1 is a negative 5. 1 times 5 is 5. So what you're going to see here is the x value is negative 16 plus 15, which is a negative 1. And the y value is 0. So the answers to this system, and remember how we normally write the answers to systems as an ordered pair? I would write negative 1, comma 0 as the solution for this system of equations.